Okay, fans, you've got to be a fan if you're coming back to this episodic reading aloud of Steven Pinker's Enlightenment Now. And we're on to chapter 2, which is called Intro, Evo, Info. And this first concept is so interesting to me. It's about the concept of entropy or disorder, or how everything tends toward disorder. And it does such a good job of explaining something that, of course, is an experience that we have every day, certainly an experience that I have. It delighted me when I first started understanding this whole relationship that we have to entropy. So here it is. The first keystone in understanding the human condition is the concept of entropy or disorder, which emerged from 19th century physics and was defined in its current form by the physicist Ludwig Boltzmann. The second law of thermodynamics states that in an isolated system, one that is not interacting with its environment, entropy never decreases. The first law is that energy is conserved. The third, that a temperature of absolute zero is unreachable. Closed systems inexorably become less structured, less organized, less able to accomplish interesting and useful outcomes, until they slide into an equilibrium of gray, tepid, homogeneous monotony and stay there. In its original formulation, the second law referred to the process in which usable energy in the form of a difference in temperature between two bodies is inevitably dissipated as heat flows from the warmer to the cooler body. As the musical team Flanders and Swan explained, you can't pass heat from the cooler to the hotter. Try it if you like, but you far better notter. I don't know this song, but they're onto something. A cup of coffee, unless it is placed on a plugged-in hot plate, will cool down. When the coal feeding a steam engine is used up, the cooled-off steam on one side of the piston can no longer budge it because the warmed up steam and air on the other side are pushing back just as hard. Once it was appreciated that heat is not an invisible fluid, but the energy in moving molecules, and that a difference in temperature between two bodies consists of a difference in the average speeds of those molecules, a more general statistical version of the concept of entropy in the second law took shape. Now, order could be characterized in terms of the set of all microscopically distinct states of a system. In the original example involving heat, the possible speeds and positions of all the molecules in the two bodies. Of all these states, the ones that we find useful from a bird's eye view, such as one body being hotter than the other, which translates into the average speed of the molecules in one body being higher than the average speed in the other, make up a tiny fraction of the possibilities, while all the disorderly or useless states, the ones without a temperature difference, in which the average speeds in the two bodies are the same, make up the vast majority. It follows that any perturbation of the system, whether it is a random jiggling of its parts or a whack from the outside, will by the laws of probability nudge the system toward disorder or uselessness, not because nature strives for disorder, but because there are so many more ways of being disorderly than of being orderly. If you walk away from a sandcastle, it won't be there tomorrow, because as the wind, waves, seagulls, and small children push the grains of sand around, they're more likely to arrange them into one of the vast number of configurations that don't look like a castle than into the tiny few that do. I'll often refer to the statistical version of the second law, which does not apply specifically to temperature differences evening out, but to order dissipating as the law of entropy. So then he goes on to talk about how entropy operates in human affairs. How is entropy relevant to human affairs? Life and happiness depend on an infinitesimal sliver of orderly arrangements of matter amid the astronomical number of possibilities. Our bodies are improbable assemblies of molecules, and they maintain that order with the help of other improbabilities, the few substances that can nourish us, the few materials in the few shapes that can clothe us, shelter us, and move things around to our liking. Far more of the arrangements of matter found on Earth are of no worldly use to us. So when things change without a human agent directing the change, they are likely to change for the worse. The law of entropy is widely acknowledged in everyday life in sayings such as, things fall apart, rust never sleeps, shit happens, whatever can go wrong will go wrong. And from the Texas lawmaker Sam Rayburn, any jackass can kick down a barn, but it takes a carpenter to build one. Scientists appreciate that the second law is far more than an explanation of everyday nuisances. It is a foundation of our understanding of the universe and our place in it. In 1928, the physicist Arthur Eddington wrote this: "The law that entropy always increases holds, I think, the supreme position among the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. If it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation." In his famous 1959 Reed Lectures, published as The Two Cultures and the Scientific Revolution, the scientist and novelist C.P. Snow commented on the disdain for science among educated Britons in his day. "A good many times I have been present at gatherings of people who, by the standards of the traditional culture, are thought highly educated and who have with considerable gusto been expressing their incredulity at the illiteracy of scientists. Once or twice I have been provoked and have asked the company how many of them could describe the second law of thermodynamics. The response was cold. It was also negative. Yet I was asking something which is about the scientific equivalent of, have you read a work of Shakespeare's? The chemist Peter Atkins alludes to the second law in the title of his book, Four Laws That Drive the Universe, and closer to home, the evolutionary psychologists John Tooby, Leda Cosmides, and Clark Barrett entitled a recent paper on the foundations of the science of mind. The second law of thermodynamics is the first law of psychology. Why the awe for the second law? From an Olympian vantage point, it defines the fate of the universe and the ultimate purpose of life, mind, and human striving to deploy energy and knowledge to fight back the tide of entropy and carve out refuges of beneficial order. From a terrestrial vantage point, we can get more specific, but before we get to familiar ground, I need to lay out the other two foundational ideas. So he just alluded to the idea that the ultimate purpose of life of human striving is to deploy energy and knowledge to fight back the tide of entropy and carve out refuges of beneficial order. But there's some more that he's going to add to that, and that's what I'm going to be covering in the next episode. So we're going to really get to understand how this law of entropy affects our lives and what our place is within that big sea of disorderliness. Thank you for being here, and I'll be back.